Good morning, friends. So today's topic is my first Verilog program. Okay, my first Verilog program I'm going to select is the ripple carry counter, which is this part. Okay, so as we observe the module basic building blocks, we have written the program for the AND gate. Now what we are trying to do here implement is the basic real time. Okay, so which is the ripple carry counter. So for this rating of the ripple carry counter, so we should have the instances, right? So we should know what is the input, what is the output. Okay. So my input for the ripple carry counter is the clock and the reset pin. Right? And my output is the Q0, Q1, and Q2, Q3, right? Which is a vector, right? Which is a 4-bit. So I'm going to declare one variable Q. Okay, and this Q you can observe here. So you have seen that first I've started with the module. The module name I have given it as a ripple underscore carry underscore counter, which is the module name, followed by parameter list, which is Q clock reset. So here also you can follow the pattern of first writing the input, then writing the input. First writing the output, then writing the input. There is no mandatory that you should follow this one. It is optional. You can write whichever you want. Why it is like that? Because at the later part, we will be declaring. Okay. So you can see I have written it as an output 3:0 Q. So it is a vector of 4-bit value from ranging from 0 to 3, which is having Q. So in the earlier figure also, design methodology, we have observed that Q0, Q1, Q2, and Q3. So it is should be declared as a vector. It is not a scalar. So you can observe here input, output, signal, and vector declaration. Okay, and these are the dash line, backslash line are nothing but writing the commands. Right? So dash dash will be explained later. Right? Then what are the inputs I have given? Input, clock, and reset. Okay. There are 4 instances for this ripple carry counter. Which are the 4 instances from the block diagram? It was T flip flop 0, T flip flop 1, T flip flop 2, and T flip flop 3. So which I have written in the board. Okay. TFF 0, TFF 1, and TFF 2, and TFF 3. Right. So this is what I have written here. So these 4 instances, TFF 0 are all nothing but the T flip flop. So this is the what we call the gate level, or what we call the switch level type. So I have written TFF, which is the toggle flip flop, TFF 0 because you have 4 instances. And what is the output of this first T flip flop? It is Q of 0. And what is the input? Clock and reset. See, in the block diagram, this is a block diagram which I am going to show here. See, these are the 4 instances. TFF 0. What is the input? Clock reset. And what is the output? Q of 0. Similarly, what is the input for Q1? Q0 is one input and reset is input and output is Q of 1. What is the input for TFF2? Q1 is the input, reset is the input. What is the input for Q3? Q2 is the input, reset is the output. So this is how I am going to write a program for the ripple carry counter. So TFF 0, Q of 0, clock reset. TFF 1, Q of 1, Q of 0, reset. So here Q of 0, Q of 1, Q of 2, Q of 3 are all output. And clock reset, Q of 0 reset, Q of 1 reset, Q of 2 reset are all the input. So Q we have defined it as an output. Here Q of 0, Q of 1, Q of 2 you are declaring it as an input. So that output value we need to declare it as a input and output value. Okay. What is those things that we will be observing as a later part we will be knowing that one. And finally, when I write the instances, finally I should be ended with the end module which are written here. Okay, which are written here. Right. So next point what I have to do is the, sorry, one second. Next point I have to do is I have written this as the main program. Okay, main program for the ripple carry counter. But I don't know what is this TFF. So toggle flip flop, what is the input, what is the output, we have not written. So how we are going to implement toggle flip flop? Toggle flip flop we are going to implement using the D flip flop. So here I have written the main program now. The main program is this one. Now I have to write the sub program for this TFF. Now that sub program again I have to write the module. So sub program TFF I am writing it as module TFF. See this keyword module element should be matched to this main program. Okay, this you should keep in your mind always. So this you are calling it as a sub program. So there should be some link from main program to sub program, and that link is nothing but by the module link. So you observe here T underscore FF, that is a file here, and T underscore FF is the instances which I am using in the main program. Okay, so when it observe this TFF, it will go to this sub program. So here also you observe what is the T flip flop. T flip flop, it is having two input, clock and reset. Q is the output. Now Q here it is not a vector. Why? Because you are not having multiple T flip flop. I am having only single T flip flop. I am initializing that one. So you are having only one output, which is Q. Now that Q here it is becoming Q of 0, Q of 1, Q of 2, Q of 3. And what about input? Clock and reset. It is sometimes clock and reset. It is Q of 0 and reset. It is Q of 1 and reset. It is Q of 2 and reset. Okay. So there is an equal mapping of which has been done. Okay. So next what I'm waiting, I am going to implement this T flip flop. So T flip flop I am going to implement using what? T flip flop I am going to implement using the D flip flop on the inverter. So D flip flop I am going to call as a function. Okay, and I'm going to use this as inverter in writing this subprogram, and that is what we have written in the subprogram. So wire D flip flop, DFF of 0, QD clock, QD are the output, clock and reset are the input. And one more gate which I have used is the NOT gate, where N1 is the name which I have given, D is the output, Q is the input, later end module. Now this is the sub program which I have written, but still what is this D flip flop? I have not written the program. For that also we should write the program, and that program I will observe here. So this is my main program, module ripple counter, clock, Q reset, where here input is clock and reset, output is 3 is to 0 Q. So in this design block you are able to understand that T flip flop I am calling. So what is this T flip flop? Sub program. So that sub program is again module TFF Q clock reset. So again I am calling D flip flop under NOT gate. So what is this D flip flop? For which again I am writing a program. So D flip flop I am writing module DFF Q D clock reset input and all those things. If reset equal to 0, Q is 1 bit 0, hence Q is D, which is your data for every positive signal. So these three programs, this subprogram D flip flop, this subprogram T flip flop and the inverter, right? D flip flop and the inverter combined together will form a T flip flop, and this will form to the main program. So when I am implementing my first program for a 4-bit ripple carry counter, all these three programs are very much required. Okay, so sir, you may be asking module N module. So this program is completed. So how it will initialize this one? Okay, so two programs I cannot write module. I have written main program, and here I am not going to write this program and end it. If you are doing that one, we call it as a illegal to next module. So here you can observe that there is a module ripple carry counter, output, input, module T flip flop, then end module. So within module, you cannot write one more module. So if you are doing that one, then it will lead to the illegal to next modules. So how we are going to write program? You have to write main program, module, end program. So this is, we call it as a main program. Then this is a sub-program, module takes of n module. Now within this, one more sub-program is there that we call it as a module D flip-flop. So there are three separate modules which can be written in a single page, but it cannot be within the module. That you need to take care. And this part we call it as a illegal to next modules. Okay, so this is the one thing. See, if you miss the semicolon, then again it is an error. If you write, if you don't get vector declaration, then also there is a error. If you write like this module within a module, then also it is a error. And if you don't declare any variable, in the variable you have given ABC, and here if you are writing input clock reset, then that is also error. So these are all the different sets of illegal statements which will create an error. And that error, sometimes it will be logical error, sometimes it will be syntax error, sometimes it will be variable insertion error. So there are different types of error available that also we will be discussing. So as of now, this is your main program which we have written for a ripple counter, and this is a sub program. So here you can see module D flip flop not get. Still one program which was missing, which I have shown to you. Right. So this is how we need to write here main program. Okay. We will continue with this simulation part in the next session. Thank you.